All right, today we're diving into a theory that asks us to throw out some of our most basic assumptions about reality. It rebuilds the universe from the ground up using nothing but pure geometry. This is wave confinement theory.
So let's just start with this one massive question. Forget what you learned about particles being these tiny little billiard balls. Instead, what if everything, and I mean everything, every electron, every quark, what if it's all just a knot in the fabric of space? A self-contained vibrating loop made of nothing but shape itself.
And that's the absolute core of wave confinement theory, or WCT. It says that everything we observe, mass, particles, you name it, is what's called an emergent property. It all arises from something simpler happening at a deeper level. It's not about the ingredients of the universe, but about how waves get tangled up and locked into these incredibly stable shapes.
So to really get how this works, we've got to look at the theory's core rules. Let's start with the first one, which is probably the most radical. It's this idea that mass isn't something a particle has, it's something a particle is.
Think about a garden hose lying straight on the ground. It's pretty relaxed, right? But what happens if you put a really tight kink in it or tie a knot? That one spot becomes tense, rigid. Well, WCT says mass is exactly like that kink. It's not some extra property that gets added to a wave. The mass is the intense localized curvature of that wave.
And what's so cool is that this isn't just a metaphor, it's baked right into the math. That little equation, m is proportional to sigma, that tells the whole story. A particle's mass is directly tied to the average curvature or knottedness of its wave. And that knottedness comes from two things: kappa, which is how much it bends, and tau, which is how much it twists. The more you bend and twist that wave, the more complex the knot, and the more massive the particle.
And that all leads to this really powerful summary from the source material. Basically, mass is what happens when a wave gets so tangled up in itself that it literally can't straighten out. It's trapped, confined by its very own geometry.
Okay, that makes some sense. But if particles are just these geometric knots, how do these very specific, incredibly orderly knots even form to begin with? I mean, why isn't it all just a chaotic mess? Well, let's get to the second rule.
The theory suggests it's all about self-organization, and the best way to picture this is with something called cymatics. You've probably seen this before. If you sprinkle some sand on a metal plate and then vibrate it with a certain frequency, the sand doesn't just bounce around randomly. No, it spontaneously arranges itself into these perfect, intricate patterns. WCT says the universe basically does the same thing.
And here's how that process unfolds. You start with just random noise, a cosmic field of every possible vibration all jumbled together. But just like that vibrating plate, the system itself has a preference. Certain frequencies, certain modes, get amplified, they grow stronger, while all the others get quieted down, suppressed. And what pops out of all that noise? A stable, organized repeating pattern, a particle.
Now, this next rule, this is where things get really mind-bending. Because WCT doesn't just try to describe what's happening in our universe. It tries to explain why our universe is the way it is. Specifically, why it has 3 spatial dimensions.
This whole idea comes from some pretty deep math in the theory. But the gist of it is that 3 dimensions seems to be the Goldilocks zone for these knots to exist. In a universe with 3 dimensions or fewer, there's just enough room for these waves to tie themselves into complex knots, but not so much room that they can easily untangle. If you had 4 or more spatial dimensions, there's just too much elbow room, if you will. The knots would have too many ways to move, and they just unravel and fade away. So our 3D universe might just be the perfect and maybe only environment where stable matter can actually last.
So let's put all the pieces together. You've got these 3 rules. Mass is curvature, order comes from noise, and 3 dimensions are uniquely stable. What kind of picture of the universe does that paint? What's the real payoff if this theory is right?
Well, the claims are pretty staggering. We're talking about a completely new origin story for the cosmos, a redefinition of particles as objects of topology. It even, and this is wild, makes a link to computer science, suggesting that the famous P versus NP problem might actually have a physical basis in the geometry of knots. It's trying to explain not just what happens, but why it happens in a universe that looks exactly like ours.
And we're going to end on this final, profound statement from the theory. Topology is not a kinematic assumption. Topology is the residue of irreversible curvature dynamics. What that's really saying is that the fundamental nature of particles, their very existence and properties, we don't just have to accept them as given, no. They are the survivors. They are the stable shapes that are left over after the dynamics of curvature have washed everything else away. It suggests a universe made not of fundamental bits, but of resilient, beautiful knots.